So here's part two. I want to go ahead and ask you to pause the video and see if you can figure out what these limits are on your own. And I'm going to go ahead and get started. Here we have a limit as x is approaching c. So again, same thing, x is approaching c. But from the right, what we see here is that the y values are approaching some number, and that number happens to be up here. And we'll call that number b. And then from the left-hand side, as x is approaching c from the left-hand side here, so from values that are smaller than c, we see that the y values are getting closer and closer to a different number. And if that's the case, we say that the limit does not exist. If the y values are approaching two different numbers, we say the limit does not exist. And if you ever have seen the movie Mean Girls, I've only seen this one part because a student brought it to my attention. The limit does not exist. The limit does not exist. Yeah, that's what she says. Anyway, I'm not a big fan of hers. She's kind of a drug addict and all kinds of stuff, but I'm sure that someday she'll clean her life up. Alright, so that's beside the point. Anyway, this one down here on the bottom, we've got the limit as x approaches c again. We see that from the right hand side, as x is approaching c from larger values than c, we see that the y values are getting closer and closer to this b. And then from the left hand side, the y values are getting closer and closer to this number n. And so again here, the limit does not exist. There you go. Hopefully you got those right. Let's look over here. So we're going to review. So I think we've kind of exhausted what we do here when we're trying to find the limit of just a regular old function. If we want to find the limit of a piecewise function, first of all, it's super helpful if you can graph the piecewise function. So we're gonna review that. This particular function is, as you notice here, the connecting real number here is 0, and that just so happens to be what x is approaching. So it's really important that we get the graph right. So if we plug in 0 into the top piece, we see that we have a slope of 1, and we have a y-intercept of -1, and so this function here to the left of 0 is a line that has a slope of 1, but it also, let me zoom in a little bit here, it also has a y-intercept of -1, and a slope of 1 looks something like that. Okay, so that part of the graph goes down there. Now the other part of the graph, as x is approaching 0, if you plugged in 0 into this bottom part, we see about a slope of 3. Okay, but this is one actually, the bottom piece is 3x minus 1, and it's 3x minus 1 when x is equal to 0 or greater than 0. So we can fill this guy in here. If we want to graph that, fill this in, because when x is 0, y is -1. And now we have a slope of 3, and so this goes up like this, a little bit steeper. So when x is greater than 0, greater than or equal to 0, we have that bottom piece. And so we see the limit. Now it's really easy to look at that graph and see that as x is approaching 0 from both sides, we can see that the y values are getting closer and closer to that -1, and so we say the limit is -1. Okay, that's how you find the limit of functions when the functions are piecewise. Okay, so I'm going to have you try this one on your own. Alright, and I'm going to go ahead and ask you to pause the video. I'm going to show the solution, and y equals x squared if x is less than or equal to 2. So if I plugged in 2, I'd get 4, and I know that the graph of y equals x squared looks like that. Okay, and right here is the connecting point right there at x equals 2 and y equals 4, so we keep that in mind. And then when x is greater than 2, we have this curve that's a line, 2x minus 1. If you plugged in 2, you'd get 3. And let me do this in a different color. Let me try pink. This has a slope of 2. The second piece has a slope of 2, and when you plug in 2, you get 2 times 2 minus 1, and that's 3. And so let me make sure I get this right. So we have this open circle here and a slope of 2, so up 2 and over 1, and so the line goes up something like that. Okay, so we can see as x is approaching 2 that the y values are getting from the right, the y values are going down here to 3, but from the left the y values are going right up there to 4, and so we say the limit, therefore the limit as x approaches 2 of f of x does not exist. Okay, and there you go. That's how you do that. Let's try the next one. Try this one as well. Okay, and pause the video. 4x minus 5, we have negative 5, 1, 2, 3, 4, 5, and I'm going to do this in yellow. So x is less than 3. I'm going to do this in pink right here. 1, 2, 3. And so 3 is the connecting point, and obviously that's where we're going to have our limit. We're going to try to find the limit as x approaches 3. And so 4x minus 5, when we, let's see, a negative 5 is the y-intercept, and we go up by 4, 1, 2, 3, 4, and over 1. 1, 2, 3, 4, 1, 2, 3, 4, and over 1. And right there. And anyway, if we plugged in 3, we'd get 4 times 3 is 12 minus 5 is 7. 4, 5, 6, 7. So right up there is we're going to have an open circle. And so the open circle is going to come down like that. So when x is less than 3, we get that line y equals 4x plus minus 5. And then x squared minus 2, let's try this in a different color. Okay, so we have x squared minus 2 when x is greater than 3. When you plug in 3, you get 3 squared is 9, minus 2 is 7. And so what we would have is, excuse me, we would have this x squared minus 2, we'd have this curve going up like this, going right through like that, right? So we'd have a parabola that has a y-intercept of negative 2, and we'll go up like that. But we can't use the whole parabola because we're restricted to a domain of x is greater than 3. And so we're going to do this. We're going to pick it up from x equals 3, and it's just kind of going up like that as a curve. And so we can see, though, that as x is approaching 3 from the right and from the left, even though we have a hole in our graph, because f of 3 does not exist, okay, just keep that in mind, f of 3 does not exist. Nevertheless, the limit, though, we can see the limit as x is approaching 3 of this function f of x is equal to 7. And 7 is the answer. Okay, there you go. I hope you guys are getting better at this. Maybe I'll try one more. Graph f of x and use the graph to find the indicated limit. Alright, so these are pretty easy because we know how to graph these functions pretty well. We want the limit as x approaches negative 1, and so when we graph 2x minus 1, let's use white. 2x minus 1 has a slope of 2, okay, and a y-intercept of negative 1, okay. But where, though, is the graph of the function when x is negative 1? So we can see we have no major things, nothing major going on in this function. We can see it's a continuous graph. We can see that there's no holes in it or anything like that. So if we just figure out, well, what's the y value here when x is approaching negative 1 from the left and from the right, what would the y value be? Well, the y value would be f of negative 1. f of negative 1 would be 2 times negative 1, which is negative 2, minus 1, which is negative 3. So therefore, the limit as x approaches negative 1 of f of x is equal to negative 3. And there you go.